sequences in series. And the first type of sequence we're going to look at is an arithmetic sequence. And that's one where you have a list of numbers, and if you add or subtract the same value, you get the next term. So looking at our example, 1 plus 3 gives us 4. 4 plus 3 gives us 7. 7 plus 3 gives us 10. And 10 plus 3 gives us 13. So it's got that same pattern between each term. The common difference is that amount we just found. It's whatever you add or subtract to get the next term. So in our first example, our common difference is positive 3. There are two different formulas we can use with arithmetic sequences. The first one is what's called a recursive formula because you spiral back to the previous term in order to find the next term, which is exactly what we did on our example. We took the first term, added 3, and that gave us the second term. Take the second term, add 3, and that gives you the third term, and so on. So this notation here, t sub n is the nth term. So for example, if I were looking for the fifth term, and then the t sub n minus 1 is the previous term. So again, using that example, if I wanted the fifth term, I would have to take the fourth term plus d is our common difference. There's also an explicit formula, which is really nice when you need to find a term that's not one of the first few terms. It's fine to use the recursive formula to get the first 5, 6 terms, but if you want the 100th term, you're not going to want to keep adding 3 100 times. So t sub n, again, is our nth term. T sub 1 is the first term. D is our common difference. And then n is the number of the term that you're looking for. So our objective for arithmetic sequences is to be able to find an indicated term in an arithmetic sequence and use the recursive formula. First thing we're going to do is determine whether or not a sequence is arithmetic. So what we do is we take the two terms and see what we would have to add or subtract. So negative 4 minus 4 would give me negative 8. Negative 8 minus 4 would give me negative 12. Negative 12 minus 4 would give me negative 16. Because I'm subtracting the same amount, yes, this would be an arithmetic sequence. And the common difference would be negative 4. For my second sequence, I would add 3, add 5, add 7. Because that number is not consistent, it is not an arithmetic sequence. And our last sequence, I would add 2.5, add 2.5, add 2.5. So yes, this is an arithmetic sequence, and the common difference would be 2.5. So first we're going to take a look at the recursive formula. We're given the first term is 3, and the recursive formula is that we are adding 4 to each previous term. So my first term is 3. If I add 4, I get 7. Add 4, I get 11. Add 4 more, I get 15. So those are my first 4 terms in the arithmetic sequence. And next we're going to take a look at the explicit formula. So this one was t sub n equals t sub 1 plus d times n minus 1. So again, what all that means is t sub n is the nth term, t sub 1 is your first term, d is your common difference, and n is the number of the term that you're looking for. So to write an explicit formula for a sequence, first we need to know the first term, which is 2. Then we need to find the common difference. As I'm looking through, we're adding 4 to each of the previous terms. So let's write this out, t sub 1. Our common difference is 4. And then to write the explicit formula, you're going to have a variable. N is the number of the term we're looking for. We don't know that when we write the formula. So we substitute what we do know. And I would simplify this, so using distributive property and combining like terms. So this is our explicit formula. T sub n equals 4n minus 2. So to find the 50th term in our sequence, t sub 50 would equal 4 times 50 minus 2. 4 times 50 gives us 200. When we subtract 2, we get 198. Our last example, this time we're given the explicit formula, and we need to find the first 4 terms. So all we need to do is sub in the number of the term. So if I'm looking for the first term, I'll substitute 1. 40 minus 15 gives me 25. Substituting 2. 80 minus 15 gives me 65. Substituting 3. 120 minus 15 gives me 105. And finally substituting 4. 160 minus 15 gives me 145.